All right, guys, my name is Tim Myers. Today I'm a senior product integration architect for VMware. TBD. Tonight I'll be a passenger on an airplane traveling home. I've been with VMware for a little over 5 years. I started in the professional services organization as a senior consultant when our professional services organization was about 20 people, and we were responsible for the entire United States. Moved on from there to a consulting architect. We built out the practices. At some point had the opportunity to move over to the engineering side of the house and try to affect things a little broader instead of on a customer by customer basis. My job is unique in that I get to have a tremendous amount of fun doing what I do. I get to touch really cool technology that some of you may or may not know about. I get to try to take the notion of virtualization and bleeding edge technology and make it all work together and then come up with something really cool to demonstrate to all of you. So with that being said, some of the things that we want to talk about today specifically is the hands-on labs. For years we've done the labs. They get popular every year. Our constant feedback is to offer more labs. We kind of shifted from an instructor-led model to a self-paced lab model a couple of years ago. This is the second year that we're doing the big showroom with 480 seats. We're proud to say that we've got over 27 different topics of labs that you can take. This year we did a lot with trying to wrap them around scenario-based implementations, if you will, to kind of give you a better idea of how to integrate our products and technology into solving specific problems and use cases. So the feedback that we've received year over year is, how are you guys doing this? We see it, it's cool, but we want to understand a little bit more. So from a hardware perspective, what I want to do is spend the next several minutes just telling you a little bit about what we did, what we're using, kind of where it sits, how it's kind of all put together. Only have an hour, so try to cover as much information as we can, and then try to field any questions afterwards. So we have this really cool event called VMworld 2011 that's happening in Las Vegas, Nevada right now. And we have 3 disparate locations that actually sit in what we're calling our public cloud. One of the locations is the SwitchNAP facility here in Las Vegas. We have the Colt facility that's in Amsterdam, and we have a Terramark facility that's in Miami, Florida. In the lab room over there, we have 480 seats. Those seats are all connected to one of these 3 facilities. We don't tell you where. We try to basically establish the same user experience for each one of these locations so that as you, the student sitting down to actually take a lab, you have no idea where you're connecting to, whether it's 30 miles down the street, whether it's 2,800 miles out. A little bit of history around what we did last year. Last year we did the actual public-private cloud model. We were leveraging View to front-end all of our student stations. We did have some hardware on site. It was really as a backup in case we somehow lost our links to any of our external facilities. This year we're happy to say that physically on site we have 0 hardware. So we went from the private-public cloud model, a nice way to kind of protect ourselves and make sure that we could ensure the integrity and the success of the labs, to really moving towards that geographically distributed public cloud model. And as I checked the notes right before I walked over, I think that we've surpassed 130,000 virtual machines that have been deployed since 2 o'clock on Sunday. Okay? What we targeted for this year was to offer the labs for 50 hours and to hit 24,000 lab sessions. We won't know kind of where we stand in that until the official end of the show. We were looking to have 18 to 20,000 labs and 225,000 VMs. Okay? These are some of the other services or some of the other courses that were actually offered. This specific one is the 4000 track on the hardware architecture. There was another one on the actual cloud and virtualization component, the core services component. Some of the other members of my team were actually giving those. I think there's some of them that are actually being repeated again today. So how do we get there, right? So one of the things that we do every year is we are challenged with the determination to use our own software first, make it all work, demonstrate it to you, the customer or the end user, and really try and identify any bugs or gotchas or anything that we can catch before it goes out the door. Part of what my team's charter is to provide feedback directly to engineering. So for these particular labs, we're using vSphere 5, we're using vSphere Cloud Director 1.5, we're using View 5. Everything inside of this environment is net new. We've went build after build after build after build over the last 4 months. Huge challenges and obstacles, as I'm sure you can kind of imagine. But at the end of the day, I think for the most part, and I'd look to kind of all of you to comment that from a lab's perspective, it's no secret that when we first start and we actually bring them all up to load, that we always have a little bit of running around to do to kind of make sure that everything is fine-tuned and tweaked. But once we get past that, the rest of the show typically goes pretty smooth. So I'm hoping that that's the experience that you guys have had. We're front-ending all of this, as I said before, with View 5. We've got 480 of the WISE P20 clients sitting there. Each one of them is configured for kiosk mode. A WISE 0 client basically means that it has no OS on it, has no operating system. It's got the Teradici chip embedded in it. That's where it kind of gets that 0 client name from. And basically what it's doing is it's automatically connecting to a View desktop that sits somewhere in the cloud. We're leveraging PCOIP to do that. And basically we have leveraged other things like View Composer to basically standardize the image that you guys all see. If we notice that there's some sort of a discrepancy, we can rev that image fairly quickly. We can recompose the pool. We can actually blow all those desktops back out, and then you guys get everything that you need. Okay. Each of the monitors today is they're DVI monitors. They're both hooked up to the actual display. The Teradici folks are working hard on basically offering a quad monitor, 0 client. They've done a lot of improvements in the video and the audio channels as part of the PCOIP protocol, and we're rapidly moving towards potentially something exciting next year that will give us the opportunity to leverage that capability as well. So for us, it was really about let's make sure the desktops are already logged in. We don't have to tell you guys anything about passwords or anything along those lines to actually establish the session. If something does happen and there's a network blip, there's a power outage, something, those desktops will automatically log back in again for you. They're automatically connecting to the same virtual desktop each and every time, and we have the opportunity to rev these fairly quickly. We also have mechanisms in place where if we were to lose one specific site link, within probably about 5 minutes we can get all those desktops redirected to another location and get those lab seats back online. Okay? SwitchNAP is one of the new data center facilities that we're actually leveraging this year. It's a phenomenal facility. There's been a bunch of tours given this year. We actually have a gentleman that I'm going to bring up, Jason Mendenhall from SwitchNAP, to spend a couple minutes of time kind of giving you an overview of what the capabilities of the SwitchNAP facility are. And as soon as he finishes, then we'll kind of pick it up and move on. All right? Thank you, Jason.
Thank you. Thanks, Tim. Did anyone make it to the tours that were offered this week over to the SuperNAP? A couple of you? Tried? Yep. They unfortunately, I think they filled up by Monday afternoon. We had this session on Monday morning and announced that we were doing the tours, and then by Monday afternoon they were all booked. So, that being said, next time you're in Las Vegas for any conference or anything, feel free to contact us and we'll try and arrange for you to get a visit out there. We're doing some really amazing things at Switch, particularly in the data center space. The SuperNAP itself, as we talk about up there, it's a 407,000 square foot facility. So that's about the same size as 11 football fields or 3 super Walmarts. So if you've ever had to run from one to checkout counter to the back a couple, 3 times, that's like running through the data center. But what's more importantly, when we built the SuperNAP, we sought to solve 3 problems that existed in the data center space. The first one obviously being scale. Everyone was tired of moving somewhere and then having to pack up after 2 or 3 years and go somewhere else. The other one was density. We wanted to be able to handle the type of virtualization that is being achieved now, that Compute's delivering, that software's like software from VMware is helping us achieve, and like what's being done with the labs. We wanted to provide an environment where that could succeed. And then more importantly, at the end of all that, we wanted to make sure we could do it more efficiently than anyone out there. Because in our opinion, when it comes to green compute, the biggest knob to turn isn't how much power the servers are consuming, because how much of our power they can consume, we're all going to use it. It's really the overhead and how you cool that. So we designed the facility, 407,000 square feet. We solved the scale problem. We committed 100 megawatts of power to that data center, which is the same amount of power as the Wynn, the Bellagio, and the Venetian combined. We put all that power into the data center, and then we said, all right, now we got to figure out a way to cool this. Well, traditional methods, of course, didn't work. You can't do an environment like that and have a typical raised floor blended air environment. We came up with a new way, and we have several patents on the way that we cool the data center, and we can support 1,500 watts per square foot throughout the entire data center. And some of the things that Tim will talk about later, you'll see how we're able to do that. The way that we accomplish that is we've created a new type of cooling, and you see some of those units, the little red units around the outside of the building there. That's a picture of our facility. You see the little red dots that align the outside there. Those are our patented HVAC system, and each one of those units has 4 types of cooling in it and a weather station. Based upon the weather, we'll choose the most appropriate method of cooling at that time in that place for us to give us the most safe and efficient method of cooling. We also have an extremely unique tri-redundant power system. So we deliver 100% uptime guarantee to our customers, and we not only agree to that contractually, but we can show you how those systems enact in place. For the 6 years that we've had these designs in place, these power systems in place, we've had 0 seconds of downtime for our customers. Now, I don't know a lot of people who can say 6 years no downtime, but we've been able to, and we're going to continue down that path. With that 100% uptime guarantee, we also offer 24/7 on-site security, fire, operational and critical infrastructure personnel. They're on-site at all times to take care of a lot of the enterprise customers that we have. And really the goal for us is to enable all enterprises, small and big, provide a world-class ecosystem for them to succeed in. Highest density, ultra-scale, and most efficient data center in the world. The second thing that we did, and this is a key piece of any data center, is you can build a great building and you can do all this stuff in there, but if you can't connect to it, who cares? Right? I'll go build this great thing out in Death Valley and no one can get to it. It doesn't matter. So you have to have connectivity. A unique thing occurred here in Las Vegas in the late 90s, early 2000. A little company called Enron with a bunch of smart guys decided that they were going to trade bandwidth between the telecommunications providers like they traded power. So they built this facility in Las Vegas because it happens to be the safest metropolitan market in America. When was the last time you heard a casino being impacted by a natural disaster? Can't remember it, can you? Because it's never happened. I was born and raised here. I don't even know what a natural disaster is. So Enron builds this facility. They're getting ready to open it. It's this amazing connectivity footprint. And about a week or two before they're ready to open, Enron declares bankruptcy. We're across the street in our first data center. Our CEO sees that. We spend the next 9 months and we acquire that facility out of Enron's bankruptcy. It gives us tremendous capability to deliver true value to our customers. We'll take that value, the combined buying power of all of our customers, and we'll use that to help lower their connectivity cost. And for the lab environment, we were able to do that, leverage that tool to help stand up dual 1 gig dedicated point-to-points that went from the lab environment back to the data center. And that's how they connected to the key environment, was through these point-to-points that did that. We stood that up in about a week and a half with the carriers we have and the contracts that we have in place. So we're really able to turn the knob with our customers and deliver the lowest total cost of ownership in the industry. Our focus with everything we do is building really the world's most powerful data center and technology ecosystems and creating the environments that can support the types of things that we're doing in the lab environment, the types of things that you're doing in your company as well when it comes to virtualization and deployment within the data center. Our goal is to enable that at every level. And we've been working with VMware through the course of this lab environment to make sure that that happened and that it's delivered successfully. So I'm going to turn the time over to Tim. I'm happy to answer questions afterwards, and we'll let Tim tell the story of what he put there.
Thanks, Jason. There's 2 things I took away from that conversation. I'm going to share with them just because it's the last day, and I know you guys have had a long, exciting week. So 6 years and no downtime, that equates to about my work schedule since I've been at VMware. And natural disaster, I live in Tampa, and there's a natural disaster in Tampa anytime I have Mexican food. Okay. All right, so guys, this is going to talk a little bit about what we have sitting in Switch right now. I don't want to get into a whole lot of detail around it, but what we have is basically some Cisco UCS gear. From a storage perspective, over there on the right, you can see that there's NetApp. Kind of right next to the UCS gear, we have EMC storage. And then over on the left, we have kind of my pet project and the latest thing that I've been working on that we're kind of dubbing the Super Rack inside of VMware right now. And that's something that I'll get to a little bit more in a little bit. That's basically a whole bunch of compute, really, really fast networking, and then a whole bunch of storage that has some really interesting and unique capabilities. So I've got a couple slides about that in a minute. Basically what we've done inside of Switch is we've broken it down into 10 different verticals. Each of our verticals have different hardware vendors in them. And essentially what we have is we have, again, the Cisco UCS gear. We have some hardware from MDSV. We have a variety of storage. And if you look really over all the way on the right, some of the takeaways from these 7 floor tiles is that we're looking at 248 servers, almost 2,500 cores, and 18 terabytes worth of memory, and a whole bunch of processing power. So this represents one of the core environments that we've actually leveraged specifically for the hands-on labs. As we go here to the next slide, this is going to talk about what we have sitting in actual Colt and Terramark. For purposes of this discussion, each one of those facilities is built out identical. It has 4 racks of actual the Cisco UCS gear with a rack of EMC storage and a rack of NetApp storage on each particular side. One of the things that you'll notice, if I go back to this, pay attention to the densities in these racks, right? When we talk about density, one of the first things that we think about from at least the data center perspective is power and cooling. And as Jason mentioned earlier, right, they're able to achieve some things that are very, very unique for their facility. And as we go back and look, you can see, at least from the server perspective, right, we're kind of limited in terms of exactly how much power we were able to put into each one of those verticals. So just kind of something to note. 64 servers in each one of these, 512 cores, 3 terabytes worth of memory, in both Miami and Colt. Okay, so as I mentioned earlier, one of the things that I get to do is I get to work with partners. I get to look at it's kind of dubbed forward-thinking technology. Really, what it is technology that people may or may not know about, companies that people may or may not know about, and how we can actually take the technology and take the vendor relationships combined with VMware software and build something that's unique and build something that's interesting potentially to you, the customer. This is something that I have been working on. I was basically challenged to come up with a solution that would be considered competitive in a cloud type of deployment. We have messaged as a company over the last couple of years that the cloud is coming. Cloud is like the latest buzzword there is. When you think about competing in the cloud with all of the different providers that are out there, kind of the one thing that comes back to mind is, what is it going to cost? How do I deploy this? How much space is it going to take up? How much power? What's the CapEx? What's the OpEx? All of those types of things. So we've really spent a lot of time focused on the white box and making sure that we have, done our due diligence and come up with a white box strategy that we feel is dense, will perform very, very well, will give you, incredible flexibility in terms of how you want to deploy it, what protocol you want to use, what storage connectivity you want to use, what type of bandwidth that you're looking to achieve, what's the minimum space that I can put it in, what's the relationship between physical server to usable terabytes. So all of that being said, this is kind of what I've come up with. Basically what we have kind of over here on the left-hand side is we have 6 blade chassis. Each one of those blade chassis is 20 servers in it. It sits inside of 7 rack units. Each one of those servers is basically dual 6-core Westmere's, 96 gig of memory, 2 10 gig NICs. I have no spinning disks in any of these servers. These servers all boot today with the auto-deploy functionality that's built into vSphere 5, right? I take out disks, I reduce power, right? I also reduce the opportunity for failure. A little more reliance on the network with the ESX servers actually booting with Pixie. However, I'm willing to take that chance because, I just like to be brave. In the middle, we have a couple of what MDSV will call their Quad V blade. And it's basically a 2U footprint, and it has 4 blades inside of it the same exact specs as the actual blade chassis. We take those 8 nodes, and that has become our management cluster. We run all of our management services in there, our variety of virtual center instances, SQL databases, Active Directory, DNS, IPAM, the whole kit and caboodle. In the middle there, we have a couple of Arista networks, 7148SXs. They're 48-port 10 gig switches, non-blocking. Arista's done really, really well from a performance standpoint over the years. The core nucleus from Arista actually came from Cisco. So we've done kind of a lot of work with them. Actually, up on the top right-hand side, you'll also see Arista switches. These are their actual core chassis switches. They make them in a 7504 flavor, which is exactly what this is. It basically is able to accommodate 4 line cards, and each of the line cards are 48 ports. They also make a bigger, larger chassis for those, kind of those larger deployments that you need. But really, this is about density, throughput, performance, being green, right, being power efficient, and those sorts of things. On the right-hand side, we have storage technology from a company called Nexenta. Nexenta's done really, really well in the marketplace. They're kind of an up-and-coming storage vendor. They've got a numerous amount of awards out there at this point. Spent really a lot of time focused on this because this was something that was kind of brand new to me. Some of the capabilities and performance that they were able to achieve at first, I was quite honestly very doubtful of. When I talk to vendors, I really don't like talking to marketing folks. I try to talk to the people that are actually on the ground and do it, and I put them in a position to force me to believe that their technology works, kind of before I'll even go to the next step. And then once I've actually achieved that, I spend a tremendous amount of time hammering on it in every way, shape, or form that I can to prove that it's not just a specific workload, but it's a variety of multiple workloads that a platform or a solution is actually able to achieve. I take that very seriously, and I work really, really hard at that. I get a lot of demands put on me, and I transfer those demands over to the vendor, and it's actually quite fun at times. So in this particular solution, what I have is basically 2 sets of storage. Each storage has 2 controllers. They're configured in a high availability pair. I have 40 gig of 10 gig Ethernet connectivity to each one of the storage controllers. I have, again, the 6-core Intel Westmere procs inside of them. These particular storage controllers have 144 gig of memory, and they are connected to 3 different drive shelves. Each of the drive shelves are capable of 60 drives each, and a whole lot of space or a whole lot of capacity and a little bit of space. In this particular configuration, my thought was there may be 2 different disparate workloads. There may be a production and a development. There may be multi-tenancy requirements or doing a variety of different testing and that sort of thing. I was really kind of happy to split these out into 2 different storage nodes. From a flexibility perspective, I could say I want my top 3 blade chassis connected to storage frame A. I want my bottom 3 blade chassis connected to storage frame B. There's a wide variety of options and flexibility there. A little bit about Nexenta. The product that we're actually using is something that's called Nexenta Store. It's basically Open Solaris. It's based on the ZFS file system. They have 3 different caching mechanisms that they use to drive performance. They're multi-protocol aware. In other words, they will support NFS, iSCSI, Fiber Channel, FCOE, InfiniBand, pretty much the whole gamut. So my particular configuration, and quite frankly, the entire configuration of the labs is all based on storage leveraging NFS. NFS is something that we've used for about 3 years now. But, again, coming back to the flexibility says this is what works for me. And, there are certain people that kind of take the ideas and concepts that we came up with, and they'll leave today, and they'll go back and they'll kind of investigate them a little bit. And maybe you're not an NFS shop, maybe you're an iSCSI shop, maybe you're a Fiber Channel shop. So I don't want to put something out there that kind of forces you down a specific path. I want to give you the flexibility and opportunity to look at this and say, if this is something that works out for you, then you have a multitude of options and choices to make for whatever your workloads or specific preferences would suggest. So essentially, what I have is 480 terabytes worth of usable storage that's sitting over here on the right-hand side. I have a combination of SSD and I have a wide variety of these. They're 2 terabyte nearline SAS drives. Kind of a final note about how the actual Nexenta Store software works. Level 1 cache is the actual physical memory in the box. That's why I've got 144 gig. Basically a whole bunch of DIMM slots with all 8 gig DIMMs in them. Their level 2 caching mechanism is really the notion of, if physical memory is the fastest cache that I can get, what's the next fastest cache? And that would be solid state. So there's some very, very prescriptive solid state disks in here from a company called STEC. They're the same company that OEMs, that the EMC OEMs and puts their disks and their Symmetrics and DMX and some of the other frames that they have. And then their level 3 caching mechanism is basically the ZIL or the ZFS intent log. And that's also a very specific solid state disk that's really tuned for the specific workload. And basically what they do is they accept all of their incoming read-write requests. That's acknowledged through one of their 3 caching mechanisms. Once those read-write requests have been acknowledged, there's an asynchronous mechanism that will actually write those pending operations out to the physical disk. So from a capacity standpoint, that's exactly why all of the physical storage is all 2 terabyte nearline SAS drives, but the actual SSD is really, really fast SSD, right? You need performance, you add more SSD. If you need space, you could potentially add another JBOD, fill it more with the 2 terabyte drives and that sort of thing. They have this notion of open storage. Open storage says, we're a software company, we're not a hardware company, and you guys can deploy on any x86 hardware platform that you deem appropriate. Now, my challenge is identifying what I think the right storage platform is. This particular storage platform is a 7-slot system. I have individual LSI controllers that are connected to each JBOD. Knowing that this was built for a cloud deployment, I assume the worst, not what I don't know. I don't know what the workload is going to look like. I don't know how demanding that it's going to be. So because I have direct connectivity and I have my workload split across multiple LSI controllers, essentially what I'm doing is I'm maximizing performance and I'm minimizing latency to my actual disks. And I have 2 dual-port 10 gig NICs in each storage controller. If I needed to shift that a different way, it's really about adding another card into the slot, configuring it appropriately for whatever you need. I could put another 10 gig NIC in there. I could put another LSI controller and add another drive shelf in there. So the flexibility is something that's a little unique that some of the other storage vendors, quite frankly, don't offer. They give you a very prescriptive bill of materials, and if you have something that you want to change, it's either not supported on that frame, or you're potentially told that you have to consider getting a different type of storage platform or upgrade or that sort of thing. So kind of coming back to that, being able to adapt and really instilling that flexibility model, that's something that's been real interesting for us. The relationship that we have is the 8-node management cluster is really kind of dedicated for management. My 120 servers that are in these 6-blade chassis are where all of my compute really lives. And then I have 4 terabytes of usable space for every single ESX server, right? Any questions on this? Okay.
This rack seems to be different from what you that you have actually deployed. So, is that because
What do you mean that we've actually deployed?
the previous slide?
Yeah, so if you see right here, this rack, these 2 racks on the left-hand side, right? Those racks right there are those racks right there. Okay? Yes, sir?
How does the Nexenta manage the RAM as a cache? Do you use power? Is there any possibility there for data loss?
I am fortunate enough to be able to put my good Nexenta friends on the spot, as they just happen to be sitting in the same exact row as you are, sir. So with that being said, I will ask a gentleman by the name of Andy Bennett to stand up, and you all have to pardon his London accent, and he would be more than happy to answer that question for you.
Okay, so basically, RAM is leveraged as a read-write cache, but all synchronous writes are acknowledged from R0 and 10 buttons. So basically, in the event, what happens is we also acknowledge that we need to facilitate flush out disk transactions from RAM, because obviously that's our fastest way to do it. In the event of a power outage, we will replay the transaction log from the cell, rewrite those back out to disk, acknowledge the file system is clean, continue to write from there. Any other questions?
Does that answer your question?
What was the IOPS that the system was expecting for? How much percentage? What is random writes, random reads?
So that was the really interesting challenge that Tim brought to me, which was, it's cloud, we don't know. Okay, we designed that system to be able to scale as Tim scales out his workload on there. And as Tim said, we've made SSD to our resilient template to get us more IO on the right side. If we have a larger working set that we need to cache from SSD, because we've exceeded the 144 gigs of RAM that we have as our level 1 cache, we can just add more to our cache that device to improve IO performance. If we need more storage, we'll just increase the number of disk drives. And we can scale that wide or we can scale that deep.
Let me give you just a quick my interpretation of your question, right? When we first engaged in this conversation, the conversation was really about, I need to build a white box stack of something that is equivalent or exceeds the technology that's present in, say, VCE or in the Cisco UCS EMC type of nomenclature, because that's what everyone is kind of knowing and seeing right now, and that's kind of become the baseline, right? Back to cloud, my biggest challenge is estimating what is that cloud workload going to look like. And if you're building a brand new cloud, the fact of the matter is that you don't know, I don't know, none of us knows. We have to take a best guess. We have to put something out there that we think will perform the way that we want it to, but we have to be cautious of the fact that we may not get it right, and we may need to have some sort of mechanism in place to be able to adapt on the fly. Kind of back to that flexibility notion. So my initial conversation with Andy was along the lines of, this is what I'm building, this is what I need, and I get bombarded like a Philadelphia lawyer with 18 questions around what are your IOPS requirements, what is this, what is that, long diatribe laundry list that you would get from any storage architect. And the answer was, Andy, I don't know. Assume the worst. Take the heaviest workload that you have ever seen and build it to that scale and give it to me, and we'll try it. And if it doesn't work, then we'll adapt, right? So a lot of the folks that they have on staff have multiple years of Solaris experience, some of them as large as 25 years. When we actually stood up our entire environment, we maxed out the CPUs on the storage controllers, okay? Their main engineer, okay, used to work at NASA, very smart, intelligent guy, said, in the 25 years that I've been involved in storage, I have never ever seen that happen on an open Solaris platform. So that's indicative of the workload and the uniqueness that the hands-on labs environment brings, right? Because 5,000 virtual machines an hour we're creating and destroying, we're cloning, we're deleting, right? That read-write operation is just absolutely going crazy. The takeaway is that we have, if you look over here, it's not actually on there, but we have the 2.53 6-core Westmere procs in there. When the show is over, we're actually upgrading those procs to a faster proc. That's indicative of the type of flexibility that we can get from something like this, because quite frankly, we don't know, right? And I don't think anybody knows.
And talking about the flexibility of the caches there, we adjusted some machine parameters on the caching algorithm, and that workload that hit us with 100% utilization is now running the labs with 100% utilization on that platform. So that's the flexibility of being able to adjust our caching algorithm and the amount of SSD we have in place to be able to take that workload change.
How would you compare yourself with, forget about the marketing part, there's something like fast cache from EMC, which I believe is similar to at least in marketing terms to what you have.
Oh, it's going to get interesting now. I'm going to sit down.
The architecture of EMC's cache is fairly similar. However, we have some ways that we handle that zero intent log for writes that's different. That caching technology that they have writes everything via a double memory path into and then back out of those SSDs. As I said, we don't write them to in and back out the SSD. In fact, if you're going to read from my zero intent log more than once a year, then we're going to be a little bit concerned, because that means that you've had 2 outages in that year of our hardware platform, which we don't kind of like. So basically, we never ever, or we hope to never ever read from that zero intent log. So that's one of the things that we do that's different. And the fact that we can scale those number of writes for IOPS by adding more and more of those SSDs into the platform. And as faster technology comes out, we can leverage new technologies for those write and read caches. So one of the things we're betting on is that Intel will come out with faster processors. SSD vendors will come out with faster and faster type of SSDs, and we can engage those things really, really quickly and turn them around, bearing in mind that we're a software platform only and we're not tied to the hardware. In fact, we're working very closely with Intel on their new Romney chipset because Intel can see the vision that we will be able to get a platform to market a lot quicker, because we don't have to spin up ASICs or custom type product to be able to leverage the power of their new platform.
Thanks for that rest. That was greatly needed.
Because you're using something that the Cisco UCS platform, it's different than what it's theoretically designed to use. Does Cisco have any issues with this? Because that's one of the places we're looking to go. We're looking at Cisco UCS, and we're also looking at a different kind of storage rather than EMC.
Any vendor is always going to come to you and say, we would like for you to use our technology, right? Any sales guy that's in business, if he doesn't say that to you, he's not really doing his job, right? So whether it be Cisco, whether it be EMC, whether it be VMware, whether it be anybody, right? The power of competition is a beautiful thing, right? Because at the end of the day, competition drives innovation. So, if Nexenta is doing really, really awesome things out there in the marketplace, and I'm a storage company, I should be paying attention to that, right? If Cisco has canned a solution and said, we're going to provide you this turnkey solution where you don't have to buy individual parts, here's a solution that we've built, we'll roll it into your data center, plug it in and go. And historically to date, since the launch of that solution in and of itself is very, very popular. That should be the writing on the wall to everyone that philosophy is a good philosophy to adopt, right? There are challenges with every hardware platform, cost, implementation, capability, and kind of all of those things. For my specific purposes, it was about how much can I pack into the smallest space and get the best performance possible at the cheapest price. And Cisco and all of the tier 1 vendors don't really play into this. And quite frankly, that wasn't even part of my focus because they already have solutions and they've already kind of are well represented, right? So this is really kind of shifting that mindset away from a tier 1 hardware vendor to more along the lines of demonstrating that white box technology, right? At the core, nuts and bolts, all of these servers come from Supermicro. Supermicro is based out of San Jose. Supermicro is Intel's white box vendor, So what does that mean to us? That means that every single time that we get new technology from Intel in the form of a seed unit, it's delivered to VMware on a Supermicro platform. Every single time that we build a new version of ESX for the very first time, it's built on a Supermicro platform, right? It gets morphed to everything else, but it starts, at least from the Intel side, with a Supermicro platform. So based on that, and a lot of the other things that we've done with them over the last 3 years, we're fairly comfortable with that Supermicro platform running ESX in a very efficient manner and knowing that at the end of the day it should just work, barring any type of a hardware failure. So, you know, Cisco, EMC, all of the other folks, yeah, they know about this. Whether they're happy about it or not, they want their business, right? And they have every right to want their business. And everyone out there that offers a product should have that same want and need. You know, everyone appreciates competition, and like I say, at the end of the day, my answer to everybody is I'm interested in the technology. That's what I do. I'm a technology guy. You know, I don't care about the name of the company. I don't care about how big they are. It doesn't really matter to me what their revenue sizes are or any of those things. Show me technology, and if that technology meets my requirements, then I'll pay attention to you. And if another company has similar technology but it doesn't meet what I need, then I say thank you, but I'm not interested. And they ask me why, I tell them why, and if they get mad about it, I tell them to go talk to their R&D department and explain to them why they don't have the technology that I needed. And we kind of move on. All right? So anyway, this is our biggest challenge, guys. This is absolutely our biggest challenge. Every year we grow. Every year we try to give you more. We try to innovate from a hands-on labs perspective. We try to increase the actual user experience. We try to give you more information. We have, you know, people that line up and people that stroll in on the very first day and at the, you know, every single morning, and we laugh because at 7 a.m. there's 300 people standing outside the door wanting to come in and take the labs, right? We see that. We pay attention to that. And at the end of the day, we absolutely appreciate that. So we have a team of people that do nothing more than spend a tremendous amount of their time focused on this, right? We've got to figure out how to put as much as we can, give you the best information that you're looking for, present it in a way that's easily understandable and gives you the opportunity to walk out with more information than you started with, right? Adopt all the philosophies of all the technology that you see around today, and at the end of the day, make it look easy, right? That's our challenge. Today, we're leveraging, you know, an insane amount of automation. Automation to the point that when the automation breaks, if we didn't have automation in play, there's absolutely no way we could even come close to this. You know, we try to work smarter, not harder. Does that always work? No, absolutely not. We're not perfect. We try really, really hard. We think we've got a good team of smart people, but stuff happens, right? And we have to be able to adapt and react to that quickly, and we have to know the right people to call in those interesting situations. We have, again, the just now available software. Numerous bugs, numerous issues, numerous integration type of things. But we want to set the example. I don't ever want to come to you as a customer and say, hey, you should deploy V5. And then you say, really, how's VMware using it? And I kind of scratch my head and turn around and look away and walk away. Okay? That's not what I'm about. If I'm going to ask you to use it, I'm only going to ask you to use it after I've personally used it. And after I've beat it 7 ways to Sunday and I feel good about what it does. And, you know, if there is something that's broke, I want to know about it. And I have no bones about going to my friends in engineering and saying, guys, this is broke and I don't believe you're doing it the right way. And at the end of the day, that conversation is really for all of you. Because I don't want you to find that out. I want to find that out. I want to find out before it leaves the walls of VMware. And I want to make sure that when it finally gets in your hands, that you can do what it is that you need to do and depend on it for your business the way you have over the last 10 years. So this is really our, you know, let's call it our dog food environment, right? That's an internal, you know, VMware term. It's really about using your own technology first, demonstrating the use of your technology in an integrated fashion. We've got vShield Edge, we've got View, we've got vSphere, we've got all of these different components, VCD. Last year at the labs, a lot of the automation was done with Lab Manager. Lab Manager's going EOL, right? VMware Cloud Director is the new upcoming thing. Okay, we took this entire thing and we switched it over to VCD. Okay, I can tell you right now, this show has been the most difficult VMworld that we've ever done in the 6 years or however long it's been at this point. You know, when I tell you that there's a whole bunch of people that have put in 20-hour days, there's no exaggeration there. I'm one of them. And I take what I do very, very seriously, and I enjoy every single minute of it. Okay? So we look for the positive user experience, right? View is a great product. PCOIP is a great technology. But if we don't do a good job of demonstrating it and hammering it and proving to you, the customer, that it works, we're not doing our job, right? The link clone mechanism that vSphere brings to the table allows you to spawn virtual machines relatively quickly when you have really fast storage sitting behind you, right? That allows you to work smarter, not harder, right? These are all technologies that we leverage. And throughout the show, we've had engineers and developers up there on the stage in the NOC showing them things that we've noticed, showing them, you know, little things that we want them to take note of in a real-world environment and go back and fix. So we've had 27 different labs. We've had 480 seats. We've had 3 different facilities that we've connected to in the cloud. It's all been front-ended by View, right? And we've done over 130,000 virtual machines since Sunday, right? That's our commitment to you guys. I don't want to stand up here and tell you about a whole bunch of stuff. I want you to go over there and see it firsthand, right? Because seeing is believing, and when you actually get to sit down and touch it and you understand exactly what it's doing, then all of the marketing hype becomes reality, right? And that's really what our integration engineering team is based about. It's based about reality, facts, not marketing. This year, all of the sponsors, all the different people that we've worked with. Every single year, we have a mission, right? And that mission is to figure out who those partners are going to be. Back in the day, we would build all this stuff. It was gear that was really being purchased for R&D and for engineering. We'd leverage it for VMworld, and at the end of the show, we'd tear it all down and we'd redistribute it in amongst the various places. Now what we're doing is we're leaving that stuff online, right? We've moved to that service provider model. We've got, you know, a bunch of gear sitting in Switch and other places. And we've got remote connectivity to those places. So now we've got this environment that's on all the time. We rev it. We get builds from engineering every 6 weeks on vSphere 5, right? We get to touch the latest and greatest stuff. We get to pinpoint the bugs and find the gaps and address all those things. That's the other part of what my team does. And we translate all that into, you know, the hands-on labs as a demonstration of VMware technology, right? EMC Cisco NetApp. Use them every year, right? Every year. The 3 facilities that we have, Colt, Terramark, and Switch, great partners to work with. They've been really, really good for us. This year we're using Arista networking. You know, again, high-dense, 10-gig, non-blocking technology, right? The Y0 clients. This year we're using Nexenta and their Nexenta storage. This is the 3rd year now that we've used, you know, MDS, you know, hardware solutions that, you know, ultimately come from Supermicro. This year we're using info blocks for IP address management, DNS, DHCP. We have 0 Active Directory integrated DNS in our environment. Zangati. We used Zangati last year. We introduced Zangati kind of at the 11th hour and didn't really get them an opportunity to get on the banners and to be able to be showcased as part of their technology. At the time, they had the ability to tell me exactly how much PCOIP bandwidth I was using, right? For anyone that's doing virtual desktop deployments, that's an important piece of information to know. Specifically since the release of 4.6, where now I can connect across the public internet, right, to whatever my endpoint is. So my WAN links are sometimes challenged. I may not have as much space as I want, and if I'm going to deploy 500 desktops, I need to make sure that I'm not going to saturate the WAN. They were able to give me very specific and distinct visibility into all of my sessions, right? They've morphed that product where they can show me NFS traffic, they can show me disk latency, they can show me anything and everything I want to know. CPU, memory, the whole 9 yards. And then this year we're actually leveraging F5 and their local traffic manager virtual edition, load balancers. We have a pair of load balancers sitting in each facility, and that's actually where all of our virtual desktops come in from, right? We have a VIP assigned to them, and if one of the load balancers was to fail, it'll fail over to the other side. So we guarantee to a certain extent, or at least have taken notice of, that's a critical entry point for us, and we have to have failover if possible. This is actually a prototype of the iPhone 5. Okay, just kidding. What this really means, obviously, is that I've kind of come to the end of the slides that I have. Obviously, we have surveys that we do. We're always interested in feedback. We take that feedback very, very seriously. That's actually really pretty. Yeah, that's really pretty. That's going to be my new wallpaper on my Mac. So I just thought I'd show you guys that too. So anyway, fellows, we have about 8 minutes. So I hope at the end of this, what you've taken away is a kind of a good, I wouldn't say it's sanely detailed, but a good overview of kind of exactly how we've built this, what we've done, some of the technologies and software and hardware solutions that we've put together that are really kind of demonstrated over in the hands-on labs. And at least for the next 5 or 6 minutes, I'm happy to take any questions. I know there's a gentleman there in the back that had his hand up. Thank you.
What's the chance of getting partners access to the labs after the show?
What's the chance of you hitting the lotto? We've got some interesting conversations that we're having, and we've been discussing that internally for quite some time. It's a topic that gets brought up every year. We've morphed to trying to record some sessions, trying to take the content, making that available kind of after the show on the VMworld website, and we continue to hear consistent feedback that people would still like the opportunity to actually run through the lab, right? It's always a challenge. Do I go to the labs? Do I go to the breakout sessions? And, it's real tough to do both. So that's a work in progress. I hope that we get there one day. I don't know what that time frame is, but it is something that's high on our priority list, and we're working really, really hard to make that happen. Yes, sir?
What are your thoughts and plans for next year's hands-on labs, knowing what you're doing?
One of the things that F5 brings to the table is the notion of having a single virtual IP address that basically load balances traffic between multiple physical locations. Today what we have is we have profiles set up on our thin client devices that point to specific connection brokers in different places. I would love to get to the point where I can say, point to this IP address and round robin throughout every single facility that we have and is part of our cloud, and that's one less piece of administration overhead that we have to deal with. If one site goes out, it automatically kills the link to that site, transfers all the traffic somewhere else, and we're there. That's one specific thing that I know is on the list. We've also had this notion of taking and offering video and audio in the labs so that you could go in and sit down, basically put on a pair of headphones, and you could have someone kind of talking to you and guiding you through the lab, and it's up to you whether you want to enable that feature or not. If you're happy with just kind of scrolling through the lab manual, that's fine, but you also get kind of that subject matter expertise, little tidbits of information that could be made available from someone talking to you in the form of a little video while you're doing that. We think that'd be pretty cool, and that's something that we've been looking at. Excuse me?
That'd be a great idea to ask questions. If you could ask questions and get a phone call, basically, to pop up with a specialist that's happy with you right there.
Yeah, absolutely. That's a great point. Today what we've done is, back in the day we used to have a large army of people that were part of the lab staff, right? Today they all wear the red shirts. And it was really, really difficult to find the right person to answer your specific question because we have so many products in our portfolio now. Having that kind of core specialist team that knew everything about every product has really kind of become increasingly difficult. So what we've done is we've taken subject matter experts that are in each one of those, different lab topics, and we've kind of put a mechanism in place now where if you're taking that lab and you have a question, it's actually displayed up on the screen, and it tells the lab number, which associates to a specific group of parties that are responsible and knowledgeable about that lab, and then specifically what station that you're looking at. So that kind of core help desk, if you will, is something that we've also worked on, and we're rapidly trying to get better at that. Any more questions, guys? Anybody? right, guys. Well, thank you for your time. I hope you've enjoyed the show.